Hey folks, today's topic is solve systems using Cramer's rule. Probably my least favorite solving technique. I'll throw it out there. Maybe you'll like it more than me. You go from there. All right, so here's how Cramer's rule. I don't know anything about Cramer. This is his one mathematical claim to fame. I don't even know his first name, but it's a pretty cool trick. I don't know how the heck he figured it out, but it is a pretty cool trick for solving systems. So I would argue our other methods are better, but still kind of cool. So Cramer noticed that if he set up the coefficient matrix 4, -2, 3, -5. This is the coefficient matrix that we talked about back when we did story problems. When we talked about X or A inverse B to use our calculator to solve matrices. So he set up as many variables. He set up the coefficient matrix, and then he set up two other matrices depending on how many variables you had. So in this case, we have the coefficient matrix, and then he made two variable matrix. He called the first one the X matrix. And what you do is you go back to the coefficient matrix, and the coefficients that were X's get replaced with the constants from the equation. So this becomes 10, this becomes 11, and then the Y coefficients are still the same values. So my X and my X switch to 10 and 11, but my Y values stay the same. Then he created a Y matrix. The Y matrix goes back to the coefficient matrix, and it replaces the Y value coefficients with the constants. So this time the 4 and the 3 are the same, but the Y's get replaced with 10 and 11. Then he calculated this thing called the determinant. So the determinant is, well, I'll give you the quick version. The determinant is calculated by multiplying these two numbers together, subtract these two numbers together. So that would be 4 times -5, subtract 3 times -2. And we call this the determinant of A. So that would be 4 times -5, subtract 3 times -2. We'd get -14. Now, let's say you forget that on the crazy off-the-wall chance that you don't remember how to calculate the determinant by hand. I get it. I'm going to show you how to do it on your calculator. So I'm going to go and I'm going to create a matrix. I'm going to create my first matrix to be that coefficient matrix. 2 by 2, 4, -2, 3, -5. So I just created that matrix. And now I'm going to go name that matrix. And I want to do, go back and clear that out first. Go back into matrix. Now, everything we've done so far has been underneath either names or edit. So let's look underneath math, and you'll see the very first thing is this called the determinant. So I have to select that first. Then I go back into matrix. I select matrix A, because that's the matrix that I called my coefficient matrix. I hit enter. I get -14 as well. So I don't care how you do it. If you want to do this, if you remember that it's this times this, subtract this times this, go for it. If you want to type it into your calculator, go for it. Like I said, this isn't my favorite move algebraically to solve a system, but it's one that you might have to see again. Determinant of X and then determinant of Y. So I'm going to calculate the determinants by the little cross thing that I remembered from Miss Lentz's class when I was in pre-calc. So that would be 10 times -5. It's always subtract 11 times -2. Do that on my calculator. I don't want to try to figure it out. Subtract 11 times -2, and we would get -28. And then finally, in our last matrix, let's do, what would be a good color here? Just go with a reddish pink 4 times 11 minus 3 times 10. 4 times 11, 44. Take away 30 is 14. So this is where Cramer's move came into play. He figured out that the little x, the variable x, could be calculated by taking the determinant of matrix X and dividing it by the determinant of matrix A. And he figured out that little y, the variable y, could be found by taking the determinant of y and dividing by the determinant of A. Which, if we take determinant of x, negative 28, and divide it by negative 14, we would get a positive 2. If we take 14 and divide it by negative 14, we would get a negative 1. And so our little x would be 2, and our little y would be negative 1. Cool, huh? Yeah, awesome, man. That's great. Oh, I love the enthusiasm, you guys. That's cool. That's great. That's awesome. All right. So, Cramer's rule. You could do Cramer's rule with a 3x3 as well. I wouldn't probably recommend it if you have the choice, but if you have to do by Cramer's rule, you need to set up a matrix for the coefficients. So I'm going to call that the A matrix. My coefficients are negative 1, 2, and negative 3. 2, 0, 1, 3, negative 4, 4. And then I need to set up a matrix for every variable. So in this case, I'm going to do 3 new matrices, x, y, and z. So my x matrix, I'm going to take the x coefficients and replace them with the constants. So these x numbers, the first column is going to become 1, 0, 2. And then 2, 0, negative 4 stays the same. Negative 3, 1, 4 stays the same. Then, I wish I would have done that in a different color. That would have been smart. Darn it. 1, 0, 2. Then we make the y matrix. The y matrix has the x column the same. The y column becomes the constants, 1, 0, 2. And then the z's stay the same, negative 3, 1, and 4. And then my z matrix, the x column stays the same. The y column stays the same. And then the z column gets replaced with the constants, 1, 0, 2. Sorry, note to myself. I'll make these look cooler next year. Now I need to calculate the determinant of each one of these. Determinant of A, determinant of X, determinant of Y, determinant of Z. So, if you wanted to do this the long way, if you wanted to calculate the determinant by hand, this is how you would do it. You would take everything in this column. Sorry, let me try again. You would multiply these 3 numbers together. Then you would add this times this, and then like Pac-Man, you come out the other side here and multiply it by that. And then this guy gets multiplied by these 2 numbers. So you would go this times this times this, plus this times that, plus this times that, minus, thought you were done, huh? Nope. Minus this times this, plus this times that, plus this times that. Now, I'm not going to do all that, especially because I'd have to do it for all of these as well. I'm just going to do this on my calc using the determinant option. And I'm going to do this one right on my screen because I have fancy calc. So I'm going to take the determinant first, alpha F3. This is a 3 by 3. And then I'm going to put in the numbers, negative 1, 2, negative 3, 2, 0, 1, 3, negative 4, 4. That determinant ends up to be 10. So let me show you again how I did that. I'll do the same thing for determinant x. Clear, clear. Second matrix. I've got to go in there and select the determinant feature first. Then I go matrix, my bad. Second matrix, determinant. Then second, not second, alpha F3. This is a 3 by 3 again. And then I put in the coefficients. 1, darn it. Okay, matrix, determinant, alpha F3. It's a 3 by 3. Okay. 1, 2, negative 3. 0, 0, 1. 2, negative 4, 4. So this determinant ends up being 8. I'll do this one with the matrix. So second matrix, edit. This is a 3 by 3. Negative 1, 1, negative 3, 2, 0, 1, 3, 2, 4. Quit. Second matrix, determinant. Second matrix, A. Negative 15. Now look, I called this the A matrix even though that's the Y. Yeah, who cares? I'm just trying to get this number here. Then we go again. I'll do this one the same way I did the last one. Second matrix, edit. It's a 3 by 3, negative 1, 2, 1, 2, 0, 0, 3, negative 4, 2. Quit. Clear. Second enter brings it up again. We get negative 16. Okay, so now don't forget at the end here, you need to calculate the actual values for little x, little y, and little z. And we find little x by taking the determinant of x and dividing it by the determinant of a. So little x would be 0.8, comma. Then we would take the determinant of y divided by 10. So negative 15 divided by 10 is negative 1.5. And then negative 16 divided by 10, negative 1.6. All right, so not my favorite move, like I said, but pretty much the only thing you need to remember is how to input the constants in which row and in which column, depending on the variables, and then just remember how to do a determinant. If it's a 2 by 2, it's probably faster to just go on your calc and figure out that determinant, mult, subtract mult. When it's a 3 by 3, I would recommend using my calculator to find the determinant. Go get them.